Okay, so this would be a problem on implicit differentiation. So here we are thinking of z as a function of x and y. So x and y are independent variables, and z is a function of x and y. We don't have an explicit formula for y or z in terms of x and y. That is, we are not given something like z is, ln of x squared plus y squared, something like this, right? So this would be an explicit here. So in red, z is an explicit function of x and y. So here we are given that z is a function of x and y, but we don't have an explicit formula for z. Instead, what we have is an equation satisfied by an input xy and the corresponding output z of the function. So the question is, how do I find the partial derivative of z with respect to x and y? So we do pretty much what we did in calculus 1. So let me write the equation again. So I have x cubed plus y cubed plus z cubed plus 6xy z is equal to 1. Okay, so let's take partial derivative of z with respect to x. So what I'm going to do is I'm going to take the derivative of both sides with respect to x. So take, so we're going to take derivative with respect to x on both sides. On both sides. Okay, so what's the derivative of x cubed with respect to x? Well, that's going to be 3x squared. So I get 3x squared here. What's the derivative of y cubed with respect to x? Well, remember, z is a function of x and y, and we are trying to find the partial derivative of z with respect to x. So when we do that, recall that we fix y. So as a result, the derivative of y cubed with respect to x would be 0. So we get 0. Now we are taking the partial derivative of z cubed. We are taking the partial derivative of z cubed with respect to x. And so what are we going to get there? Well, that's going to be that's going to be 3z squared multiplied by partial derivative of z with respect to x. Okay, and so now we have the third term here, and the third term we have to think, so third term I'm going to think of that as so 6xy, that's a function of x and y, and then we are also thinking of z as a function of x and y. So I'm going to apply the product rule there. So by product rule, I take the derivative of 6xy with respect to x, that's going to be 6y multiplied by z plus 6xy multiplied by the partial derivative of z with respect to x. And on the right hand side, since it's 1, I'm going to get 0 when I take the derivative. So once I have this, now I have to solve for the partial of z with respect to x, which means I have to isolate that on the left. Okay, so any term that doesn't have partial derivative of z, we're going to move that to the right. So I'm going to be left with 3z squared partial derivative of z with respect to x plus 6xy partial derivative of z with respect to x, and on the right hand side I'm going to get negative 3x squared minus 6yz. Okay, so now on the left hand side I can factor out, so I get 3z squared plus 6xy multiplied by partial of z with respect to x, which is equal to negative 3x squared minus 6yz. Okay, finally I'm going to divide. So partial of z with respect to x is equal to negative 3x squared minus 6yz divided by 3z squared plus 6xy. Okay, so that's the partial derivative of z with respect to x. So this is the equation that we had, and given that equation we found the partial of z with respect to x. Why don't you go ahead and try to do the same, but find partial of z with respect to y. So go ahead, and I'm gonna give you 2 minutes to see if you can find the partial of z with respect to y by following what I did.